So we're live, ready to go. Let's see what's the challenge for today. So let's go on to the Advent of Code website and let's see today's challenge. So now that we are satisfied with the search on Ceres, or Ceres, however you say it, the squadron of scholars suggests scanning the stationary stacks of a sub-basement. Okay. The North Pole department is busier than ever, and while the historians continue their search, an elf is operating a very familiar printer, which we don't know, so... Okay, oh, day 1 of 2017. Okay. Keeps referencing older challenges. So, we have an elf with a printer, and he's calling ours. The elf must recognize me, because they waste no time and explain that the safety manuals are not printing correctly. Okay. And we offer our services. So, as nice IT guys, we just offer to fix their printer, as always. Safety protocols indicate that new pages for the manuals must be printed in a very specific order. Okay, so we have ordering today, which is way more difficult than the matrix. I hope it's not. The notation means that if both page number X and Y are to be produced, page number X must be printed at some point before the page number Y. Okay, so this is defining some ordering rules. The elf has for you the page rules and the pages to produce. Okay, but it cannot figure out whether each update has the page. Okay, so we are printing the manual and we need to know if the manual is in order. Okay, so we have this input. The first section defines the rules. Okay. And the second, I think, are the sequences, the prints we have to check. Okay. So to get the printers going, we need to identify which updates are in the right order. Okay. This is the explanation of the example. So he's explaining every line, and then they need to know the middle page number. I think there will be a sum here. Okay, so we need to sum the middle page's number of the correct sequences. So add this page number together this number. So this is our result. So let's scaffold day 5. Compiling a lot. Okay, so we have our example, which is the one on the website. This one. Here. We have the input, which is way longer. Okay. And we have our file. We will check later. So I think, yeah, we still need to load all of this. So let's start with a big test and just solve this without unit tests. I don't have time today. Sum of 143. So let's start by reading the inputs. How can we represent? I mean, we could represent it as a graph, but I don't want to deal with graphs today, or at least I don't want for now. So we can like load the an hash map to check the rules and vectors for the sequences, maybe. So let's start with that. Let's say the rules. We have an hash map. Of our numbers. Are they all unsigned? This is the example, but in the inputs, yes, they are all unsigned numbers. Okay, so we have 2 unsigned numbers. We create a new. Oh, let's zoom a bit. Can you see it better? Okay. Now we need to have also the sequences, but we will get to that later. How can we do that? lines is input.lines. We should be able to read this until it's empty, so we get to the first empty line to load the rules. And given that this lines is actually an iterator, we can mutate it and use it for each new line. So while we have a new line which is lines next, if let's load first the rules. So if the line is empty, we break. Otherwise, we need to read these rules. So we get the line. We can split the line once because we have two numbers. So split once should give us an iterator. And this is split. We split on the pipe character. Again, this is mutable because then we do let the previous number in our order is split next. It's not a next. Okay, so split first. How can we? Oh, it's already giving our options. Okay, so we can just unwrap, and here we have rev and next, right? Don't need to be mutable. So we have strings. We can override the previous. So it's previous parse unwrap. And this is an unsigned number. Same thing for the next. It's unwrap. And now we can add it to the hash map. Now, why isn't it working? I need to import the hash map. It will not work. Do we need a hash map? I mean, we can just check if the rule is there, maybe. Oh, I have an idea. I want to try. So we can do rules insert rev next, and these are our rules. Oh, this hash set doesn't work. Okay, now it's working, and let's try to see if the rules are okay. So debug rules and return sum of 1 to make it fail. Let's test the binary 05. So it is failing. And we are getting some rules, which are, let's try with the example. Oh, they are not in order, but it's okay. I can see that there are numbers like 97, 61, which is right. And so on. So I think we loaded them correctly. Now, we have the rules, and we can load the sequences. Now, we already have the lines iterator, so we can just do lines. We can map it. So we have a single line. We extract the numbers, so we split on the comma. We map this to, now here we have a number or a string actually, which we can parse. So as parse as u32. We don't care about the format. And each line is need to be collected, and these need to be collected too. So we have our sequences, of which is a vector of vector u32. We need to check these. Let's see if the sequences are okay. So bug the sequences, and we can test it. We have right sequences 75, 47, 61, 50. Okay. Last one is 97, 13, and 47. Okay. So we have the sequences, we have the input. I think we can extract this, but we need to test, to have the test pass and to solve it before doing that. How can we check that a sequence is ordered? So if I have a sequence like 75, now I encounter a 47. How can I be sure this works? Now we can go on the demonstration by, I mean, we can try to reverse the condition. So we need to check that it isn't sorted. Should do that. So if we encounter 47, it is not sorted. If we cannot find, I mean, if we find 47, 75, it is for sure not sorted. So we need to check for the reverse of this. Let's see. And the thing is, this algorithm is O of n squared, because we need to check all the previous sequences, but I think the sequences are small enough to let us do it for a brute force approach. I mean, brute force. We still have a hash set for the rules, so we can check it way faster than with a sequence. So for each sequence, we want to filter every sequence. Now, bear with me. For every characters, let's do it with indices. So for I in 0 to slen, and for j in 0 to I, so up until the last character we selected, we do if the rules contradicts us. So if there is a rule with a value of s of j, s of I, then we return false. So we don't consider this sequence to be okay. Otherwise, we go on until the end and we return true. Now, why does this doesn't work? Okay, he wants a reference of this. Okay, we return true, we filter them, and then we want the element inside of it. So if we have a sequence, we want the middle element, so hope they're all odd. slen over 2. We want to sum them, and we can just return this number. Right? Are you okay with this? Is not okay, because we need to iterate over the sequence. Nice. Let's try. It is failing. Still is getting 0. Okay. So why is it not working? Oh, okay, so the I is actually the one on the right. So we should, I, if we get this sequence, I goes from, let's try to see with an example. So at the beginning, I is here. After that, we have I here, and here is J. So we need to check that there's a IJ rule. If there's a rule which says 47 must come before 75, so it's I 47 before 75, then the sequence is not in order. It works. Wow, on the first try. So let's try to solve this. Solve 05. It returns a number which I might like. Wow, We already solved that in, I don't know, 10 minutes. Let's try to see the second one now. So first of all, let's refactor a bit this shit. I want at least to extract this method so we can, let's try to see the second part. While the else get to work printing, so with our correctly ordered print, we have now a little time to fix the rest. For each of the incorrectly ordered updates, we use the page ordering rules to put the page numbers in the right order. So we need to sort the sequences using the ordering we have here. So these are the incorrectly ordered updates. We want to transform them after taking only the incorrectly ordered updates. Their middle page. Okay, so we need to sum the middle pages of the incorrectly ordered sequences now correctly ordered by us. So we need a 1, 2, 3. I hope we can do that. So first of all, let's extract this method for the inputs. So we want to load them. We get an input string. We return a tuple with hash set of u32 and a vector of u32. This is our code, and we return rules sequences. Let rules sequences be load inputs of input. Is it still working? It is. And given that we have to still check the sequences, let's extract this method here. So I hope VS Code can do that. Yes. So check order of a sequence. Let's call it sequence given the rules. It's returning an option. Why? I don't know. I just want a boolean. True, and we return false. Also, I don't need all of this. I can just do that. Check order rules. He doesn't like rules. Cannot move out of rules. So we want a reference to the rules. We can give it. The sequence is a double reference to back. I hope it's working. And let's try to see if it works again. Okay, so the code is way clearer now. Let's move this up so we can forget about it. So for part 2, we need to return 1, 2, 3. And this is our goal for today. Obviously, it's not. Let's load the rules. So again, we have rules and sequences, load inputs. Now, what we can try to do, and I was thinking about this, is sorting. Like, you know, there are some languages which implement comparison operators, and we can use the comparison operator to implement the sorting. So, for example, I remember in C++ there was a compare, but also in C#, and there must be a Rust comparison operator expression. Oh, stdcmp seems like the right thing. And can we sort with this? min max. Sort custom comparator. Sort vector. Let's start from the cookbook. Sort vector of structs. So here we have a custom comparator. We have, but what does CMP return? So Rust CMP. What does a CMP return? This is the module, but I want the function. So function max min. No, I just want this CMP. So like fast CMP method. Ordering. Okay, so we need to return an enum from this. Okay, so the first against the second. We can do that with, I mean our rules are okay for that. So given two numbers, we can compare two numbers, and we can do that. Compare a number, which is A, with B, which is another number, given the rules, which are our rules. It returns or ordering. So this is the right one. Now, how can we be sure? So if the rules contain the value A, B, this means that A is less than B. So we return ordering of less. Else, if the rules contain BA, we can return ordering of more of what is the other value? Greater. Otherwise, we can return ordering of equal. I mean, they're not equal, but it's okay. Okay, so it wants, yeah, return. Yeah, I know it's not idiomatic code, but it's okay. That's okay. So we have a compare operator. We can sort the sequences which are not okay. So for each sequence, we get only the sequence which is not in order. We create a new sequence. So given a sequence, we have to sort the sequence. How can we? So sort. How do we sort? How can we sort? Oh, there's also a is sort. We should use that. Okay, so sort doesn't get any custom parameter, but sort by gets a comparing function. Okay, it is exactly our function. So we can do s, not actually s, because we need to copy that. So click sort by, and we pass our comparison, which must be a function which returns ordering. So it needs to be a function mutable of ordering. Let's copy this code and we will extract it later, maybe. So we get A and B, and we'll just copy our code. Okay. This is the sort by, this is the map. Now here, actually we need to do this. So we need to first declare a new s, which is s to back, and then we sort the thingy, then we return the thing, and we close. And let's format, otherwise I won't understand. So maybe there's a sorted which copies. Sort by, no. Yeah, okay. So let's remove this this one for a bit and put it back into where it belongs. And then let's do it again. So we have S, we copy it. So S is equal to S to vector. Now S, oh, the filter is not working. Ah, okay, yeah, as always, iterate, filter. Now we have a vector. We have to make it mutable. So mute S sort by another compare function, which is given A and B, we compare A and B given the rules. This should work. S sort by, we return to the map operation. Doesn't like it. Now for every new sequence, we need to map again. Given the sequence, we do the same thing that we did in part 1, which was this one. So we get the middle element and we sum them. And we return the sum of this. This should be a reference here. And we can test this. Okay, no, it doesn't like it because why? Change the closure to take multiple arguments instead of a single tuple. Line 56. Ah, okay, because the sort by doesn't take a couple, but it gives us 2 parameters. Okay, and here we need to pass the. We can do this maybe. We get a reference to them, so we don't move. Oh, here it doesn't like it. Consider the referencing. Okay, so with the reference, the borrow. Even if I don't like this. Okay, I mean, the compiler should like it. And it's also passing. I'll go solve 0.5. It was also fast. I mean, I'm not looking for the times, and this will be for sure a lot longer than expected. But it's right. And so we did day 5. Now we have a new line in our solution. So, well, nice. I mean, I did it very fast. And let's see if we can, like, I want to play with this. So let's return the function instead. So we can create the function one time. We can create the comparison. So let's write a new one. I want a function comparator given the rules. Now that we solved the problem, we can have fun. And we have a U32, U32 here. We want a function mutable, which is the one sort by wants. Sort by wants a function mutable of 2 references, returns an ordering. So we return U32 and we go back with an ordering. Will it work? No. We want to return a function. Can we do it like this? We get 2 parameters and we return this thing. Does he like it? I don't think so. I mean, if we can do this, maybe. Is it that easy to use lambdas? No, it doesn't want. Cannot have an unboxed straight object. Doesn't have a size known as... Okay, consider to be an impl trait. Can we do this? No, it doesn't like it. Hidden type. Captures lifetime that doesn't appear in bonds. Add a used... No. What if I do this and see what it returns? No. Consider disclosure a parameter. Explicit type. Okay, so A is a reference to U32, B is a reference to U32. No. Expected found closure. Impl fn ones. Let's see. Rust create fn. Rust function return closure. Return closure. Aha. Okay, so we can try this. We can try with move. This returns an impl fn once, which I don't think it's the one we want, but let's try to return what he is expecting. So fn implementing fn mode of whatever he wants, which is fn mode of deity ordering fn mode of u32 doesn't like this because again the same thing. This was easier. A plus B and rules. Boxedin. This is more difficult than expected. So hidden type. Opaque type. Fine here. Hidden type captures the add a use bound to explicitly capture. Let's see this error where it goes. Use. Never seen this. Okay, so Rust 2024 is the culprit. Return position implementation trait. Okay, the use of implementator means that the function returns some kind of iterator. However, the compiler generates code. Okay. An impl trait value can only use a reference if the lifetime of that reference appears in the implementation trait itself. Okay. Error message. You need to give it a lifetime, basically. So we need to give it okay, we need to give it an explicit lifetime. Oh, actually, oh, that's okay. We just need it, and this is the, as they say, the hash set, and this returns the. This is the. It returns an ordering which is the lifetime, and it works. Okay, so let's comment this for now. So now it doesn't work here. This sort by can be replaced with a comparator, which is comparator of rules. And we can pass this to the sort by. Right? Wrong? Wrong. Why? Because he found an implementation of something. Is not implement. Okay. Expected a closure with given arguments. Found a closure with given. I mean, this is just the same. It must implement fn mute, but it must implement fn, which is motor general. Well, I think this can implement an fn. It's the same thing. It's still not working. Cannot move out comparator. Capture variable in fn. Okay. Let's give it a reference. That works. And it's working. Okay, so we have comparators. Now, can we sort back? I mean, can we do this in one single line instead of doing that? Like, is there a sort which copies the data? Copy and sort. We're already doing that. Sorting, time and space. Sorting with sort. Sort by, sorting custom types, performance. Swap in place. Sort by, closure patterns. Reverse sort. Sort keys, references, sort by slightly slower. Additional tips, mutable slice. You can sort slice, okay. Parallel sort, partially sort. No. But at least we have this. This is our solution. We like it or not? Same thing we can do in part 1. So for example, here, instead of doing it by end with this check order, the check order can receive a comparator, or we can just create the comparator, which is comparator given the rules, and we can, instead of check order, we can just do s is sorted by comparator. No. Expected something to be a reference that returns bool, but it returns ordering. Okay. Why? Because is sorted by returns a boolean. I mean, okay. Okay, so the comparator is sorted is not the same as sort by. So let's go back. Back. Let's go back to back and is sorted by. Is sorted by needs a comparator which returns a boolean, so it's not the same thing, but we can try. We need a comparator and we need two numbers, so given a and b, comparator of a and b, reference. Comparator is a function. Is no, we need to see is greater. No, a must be less than or equal to b. And it works. Now, it's not so nice to see, but I mean, if we make it like this and put a tab in here and format everything, it's quite nice. And again, we can remove the check order because we're not using it. Now, which one is faster? I don't know. I should see the is sorted, but we don't know that. I mean, it just used the give and compare function. I think it does the same thing. And for now, we are okay with this. I'm still checking the order here. So we should, again, use the is ordered from part 1. So S is sorted by here. So if it's not sorted by this, then we check it. Okay. And okay, this is done. Now let's add it here. I don't forgot about the other AOC 2024 day 5. And we're done. Now another thing I wanted to do now when I saw the problem is to visualize the graph of these dependencies. So let's start with the example and try. I just looked for this pet graph, this graph library. So let's try to print the graph of dependencies, because another thing I wanted to see if there was a topological sort to that. Still, it would have been n squared, but we can add a beta graph, which is the library I just seen. Oh, it's not here. Graph, sorry. That graph, and we can try to create the graph. So let graph be this. I'm just looking at this. So let input is this one. Let's comment this for now. Graph. You like it? You don't? Import. Now we load the rules. So we load the rules and nothing, which is load inputs of input. Now for each rule I want to add something to the graph. Graph for each rule. So rule for rule in rules, and rule is 32 is a rev next. We can add, no, we need to add all the nodes in here. So let's create another hash set for all the nodes. Hash let nodes equal to rules map, no, rules iter map given a tuple A and B. We want to, actually we can do a flat map because we return a vector of A and B. Maybe this will return a vector of numbers. I hope so. We can check. And now for each node, can we do like, how does it work? Graph add node index. Add a nodes with associated data weight to the graph. Return the index. Oh, okay. So for each node, okay, got it. We return a hash map here of U32, which is the index, and U32, which is the node. Now this is the number, this is the index, okay? So given the flat map here, for each node, we see if the graph already contains. Now let's try another thing. We get a hash set of U32. These are just the single nodes. we collect them for each node. So again, for each node, we now create the hash map. So the node is this. We do graph add node. We don't need a wait. I hope this is 1, and this should return the index. And we want to add the number and the index, and we want to collect. Okay, and these are the nodes which have become a hash map of U32 node index of U32. From beta graph. Okay, cannot be built from an iterator of elements. Okay, iterate. Okay, I need to return a reference to them. This works. Now, given the nodes for each node, now these are the edges instead. So we need to add a graph add edge of A is a node index, B is a node index. So the first node index is nodes get a prev. Prev, he doesn't like this. And this is actually, let's do it with next. And let's give it a weight of 1. It works. This collect doesn't work. Value of hash set cannot be built from an iterator over type of. Okay, so we need to add the references again. And the final thing I want to do is to print the dot. Oh, this is a dot already. I want to print this. So let's just copy this. I want to print the graph. Wait, so import and import. Now, what if I try to solve 0.5? It's not working. Okay. The add edge needs a reference, the reference node. Why? Need to reference this, maybe. Okay. And I expected arguments of these methods are incorrect. Now, he wants a node index. He wants a node index, and he wants an edge. Oh, wait, which is? We don't know. No. NETYIX, edge type and index type. For edge type, I don't know. Index type, I don't know either. This one. Expected nothing, found integer. So it's okay. This is what I was talking about. So this is for the input. So let's try to print this onto a dot file. And so 0.5 graph. We have our dot file. Let's try to print it. So in a PDF, dot PDF. Dot to PDF. Oh, come on. Dot PDF. PDF. Come on. So dot tsvg of, how did I call it? Graph. Will it work? I hope so. He's doing a lot of stuff. Let's try with the example first so we can check. Now let's read examples 05 and create the dot and SVG. Okay, is there a PDF? Yes. No, we have the we can see the SVG, so graph dot, we can open it like with Chrome, so graph SVG. And if I open this in Chrome, no, if we open the folder, open the SVG, ooh, okay. Now the notes doesn't have names, but we can add the names because this weight here is instead n. So if we create the dot file and create the SVG and open the SVG, we have numbers. This is really nice. Okay, so this is the ordering of our example. Nice. Let's see the inputs and then we are done. Cargo solve, the SVG. Let's wait for this to work. It will take a while. How is the PC running? I don't have HTOP. Oh, okay. Okay, finished. I don't want to see the performance. And this is okay. It's not. Oh, that's a big graph. Okay, it's having trouble printing it. Can we print it in topological order? In dot print. Brackets. Ordering. No. Okay, we can take care with. We can be happy with our example, which works, and it's not melting my computer. So this is it. This was day 5 of Advent of Code. Thank you for anyone, so no one, who watched this live stream, and see you soon. I don't think I will do day 6 in live streaming, but maybe I'll do day 6 and 7 together if we have time on Saturday. So thank you for joining if you joined, and see you.